Hello students, welcome back to my YouTube channel Data Shah. I have started a new series, the new playlist in which I am talking about probability distributions. In the previous lecture, I have talked about the discrete random variable. In today's lecture, we'll be talking about the continuous random variable. So unlike the discrete random variables, the continuous random variables do not have the probability distributions functions, specifying the exact probabilities of their specific values. Instead, the probability distribution is created by distributing one unit of the probability along the real line. Such a distribution is called as probability density function, which determines the probabilities that the random variable falls into specific intervals of values. So there are certain characteristics that you need to understand and you need to prove if we are given, if you want to check that whether the function is a probability density function. The first one is that the area under the continuous probability distribution is equal to 1. This means that from minus infinity to infinity, your fx, if fx is my probability density function, then the integral, that is the area under the curve, has to be equal to 1. The second point is the probability of the random variable x lying between a to b is equal to the area under the probability density function curve between the points a and b. So that means p of x, the probability of the random variable x, if it is lying between a to b, is nothing but the integral a to b fx dx. So that's the area under the curve. The last point is that the function is always greater than or equal to 0. That means we can say fx is greater than equal to 0 for all x. So whenever we need to check whether a function is a probability density function or not, we need to check the two conditions. First of all, fx has to be greater than equal to 0. And the second one is area under the continuous probability distribution has to be equal to 1. So let us consider one question related to this. Um, is the function defined by fx, where fx is defined by this, x is less than 2, 3 plus 2x, if it lies between 2 to 4, and it is 0 if x is greater than 4. Now we need to check, is this function a probability density function? The second part states, find the probability that a variate having fx as the density function will fall in the interval the given interval. Now, one thing we need to remember, whenever such a question is given, it is not mentioned to us whether it is a continuous random variable question or a discrete random variable question. So in the question itself, we can figure out which kind of a variable they are talking about. Whenever we have probability density function or a density function, that means we are talking about a continuous random variable. Whereas in the question it is mentioned probability mass function or just a mass function. This implies that we are talking about a discrete random variable. So first of all, in this question, we need to check whether it is a probability density function or not. So we'll start with that. To check fx is a probability density function, so I am using an abbreviation PDF. So for this, we need to check two conditions. First, that fx is greater than equal to 0 for all x. Second, minus infinity to infinity, that is the area under the curve, has to be equal to 1. So one by one, we'll be dealing with this. Now, when we are talking about the solution of first part, that is fx is greater than equal to 0. So as we know, as fx is equal to 0, when x is lying between minus infinity to 2, it is 3 plus 2x upon 18 from 2 to 4, and it is again 0 from x greater than 4 going up till infinity. So this is what we have. So as fx is given to us, so now here you will see less than 2 is obviously equal to 0. Greater than 4 is also equal to 0. And whenever we put any x value in between 2 to 4, so because this function fx 3 plus 2x upon 18 will give us a positive value only. So as fx is given to us like this, so fx is greater than equal to 0 for all x values. Like from, we can say, you can also write here, fx is greater than equal to 0 when x is lying between minus infinity to infinity. Now, the second part, we need to check what is minus infinity to infinity fx dx, the integral. So, we need to break the integrand here, and the integral would be minus infinity to 2 fx dx plus 2 to 4 fx dx plus 4 to infinity. Now, how do we decide that at which point we need to break? It is given in the question. So, minus infinity to 2. So, I have taken that particular limit. 2 to 4. So, the second integral limits would be from 2 to 4. And the last one is 4 to infinity. So, this is how we can select what we need to take. Now, moving ahead, you just need to solve it. Minus infinity to 2, fx is 0. So, this is just 0. Two to 4 is given to us. And from 4 to infinity, it is again 0. So, we'll be solving this, and let's see what we get as the answer. So, I can just break it. So, this would be 3 dx plus 1 upon 18 2x dx. So, I'll get here applying the limits. So, because this is a definite integral, we'll be applying the limits, and finally we'll be getting the answer as, and this would be 4 square, that is, okay, I'll write it like this. So, this would be 2 upon 6 plus 1 upon 18, 16 minus 4. That's a 12. So, I'm just left with 2 upon 6 plus 12 upon 18. So, that's 6 upon 6, that is equal to 1. So, ultimately, I am getting here that minus infinity to infinity fx dx is equal to 1. Thus, fx is a probability density function. So, this is how we can prove a function to be a probability density function. Now, there is another part here that we need to find out. Find the probability that a variate having fx as the density function Now, variate means we are talking about the variable capital X. So we need to find the probability of the capital X variable having fx as the density function. So this fx would be the density function for that particular random variable, will fall in the interval 2 to 3. So now what we need to find? The probability of the random variable in the interval 2 to 3. Now what this would be equal to? One thing that we need to understand here, whenever we are talking about the continuous probability distributions, that whenever we are talking about the continuous random variable, so I'll whenever we are talking about this, you need to understand that P of probability of X lying between A to B, the inequalities, it's not strict, less than equal to is given and greater than equal to is given. This is equivalent of this, which is equivalent of this, which is equivalent to this. So whenever we are talking about the continuous random variable, all of these probabilities holds the equal value. But this is not the case when we were talking about the discrete random variable. There we need to take the sum accordingly. But here, because we are talking about the area under the curve, we are talking about the integration, so it doesn't matter. So that means what we need to find out when we are talking about the probability of X lying between 2 to 3. So this would be the area under the curve where X is lying from 2 to 3 fx dx. So as we know, the function, the density function, the value of the density function between 2 to 4 is given to us. So this is 2 to 3. So it would remains the same. So I will just take it as. And we could similarly find out its answer. So it would be 3 upon 80 x plus 2 upon 18. So finding out the value, this would be 3 upon 18. This is my 9 minus 4. So 3 upon 18 plus 5 upon 18. So we are getting 8 upon 18 as the answer, or I can write it as 4 upon 9. So this is the probability of X lying between 2 to 3 is coming out to be 4 upon 9. So this is how we get it. So it's very easy to find out the probability density function to check whether you are getting the correct answer or not. Now, let us consider one more question in this regard, where we'll be talking about a constant in the PDF and how we can find out its value. So consider a continuous random variable, and if the PDF, the probability density function fx is given by axq, where x lying between 0 to 3, and it is 0 elsewhere. So this is the PDF. Then find the value of k. So that's very easy and simple to find. Now, what does this mean, 0 elsewhere? This is equivalent of saying that our fx is equal to We know that whenever x is lying between 0 to 3, kx cube is the value. What about when we are talking about x less than 0? That means when we are talking about x from minus infinity to 0, it is elsewhere 0. So the function value from minus infinity to 0 is 0. It is kx cube when we are talking about 0 to 3 interval, and it is again 0 from 3 to infinity, the real line. This is how we can describe our function. So just need to find out the value of k. So we will consider here as fx is a PDF. So the integral minus infinity to infinity fx dx has to be equal to 1. So using this property, we can find out the value. So breaking the integral, so minus infinity to 0, then 0 to 3, 3 to infinity. Now just substituting the value of fx. So we get here this equation. So this is nothing but 0, k times integrating x cube will give us this value. This is k upon 4, 3 raised to power 4 minus 0. 81 minus 0 is just 81. So what would be the value of k? We can take this 4 on that side. So this would be this. So k would be equal to 4 upon 81. So this is how we could find the value of k. So very easy to find out the value of k using just the definition of the probability density function. So moving ahead, we'll talk about the CDF in this. So let us come to the next page. The cumulative distribution function. Whenever we are talking about a cumulative distribution function, we are talking about the definition remains the same. There is no change in the definition. So let me just write down the definition. It is denoted by capital Fx, that is P of capital X less than equals to X. But when we were talking about the discrete random variable, there the cumulative distribution function, we were finding out the summation. Here, we'll be finding out the integral from minus infinity to x, fx dx. And here we need to remember that x is lying on the real line. So we have certain properties of CDF. So let us consider that. So the first property is that the fx lies between 0 to 1. So it is same as we discussed in the discrete random variable whenever our x lies on the real line from minus infinity to infinity. The second property is that if x is less than y, then fx would be less than f of y. It could be a strict inequality or it could be less than equal to, then fx would be less than equals to f of y. Also, f of minus infinity is 0 and f of plus infinity is 1. And the last property is the small fx, that means the PDF that we have is equal to the derivative of the CDF. This is true at all the points where fx is differentiable. So let us consider one questions on the basis of this. Consider a probability distribution given to us as df is a times exponential function e raised to power minus 2 mod x dx, where x is lying in the on the real line. We need to find the value of the constant a. So how will we find the value of the constant? So here, as we have just studied the fourth property, that fx is the derivative of f dash x, that means it is d of f. So considering the same, and I'll be just taking this minus infinity to infinity fx dx is equal to 1, because fx is a PDF. So just substituting the value of the function here. So that is nothing but a times e raised to power minus 2 mod x dx is equal to 1. Now, because we have a mod x here, so now how can we break the integral? It would be less than 0 and greater than 0. So whenever we have x less than 0, the mod x value would be, as we know this, mod x is minus x whenever x is less than 0, and it is positive x whenever x is greater than equal to 0. Equal to 0 whenever x is equal to 0. So we'll be breaking this as minus x dx plus 0 to infinity plus x. So as a is a constant term, it will come outside, and we are just left with e raised to the power 2x dx. Here also is a constant term, it will come outside. This would be e raised to the power minus 2x dx. Now the integral of the exponential function is the exponential function itself, and this would be equal to e raised to the power 2x divided by 2 minus infinity to 0 plus a times e raised to the power minus 2x divided by minus 2 from 0 to infinity to 1. So constants outside, e raised to the power 0 minus e raised to the power minus infinity e raised to the power minus infinity minus e raised to the power 0. Now, as we know that e raised to the power 0, e raised to the power 0 is 1, and e raised to the power minus infinity is 0. So considering these values, I'll just write here. So this would be a upon 2 plus a upon 2 is equal to 1. So that means this is nothing but a is equal to 1. So here we'll get the answer as a equal to 1. So this is how we can find out the value of a constant whenever such a kind of a question is given to us. So in this lecture, we have discussed what is a continuous random variable and what is the CDF, the definition of a distribution function. We have discussed certain questions as well. So stay tuned for the upcoming videos and do subscribe to my YouTube channel, like and share. And for the upcoming videos, please hit the bell icon so that you can get the new updates regarding the same. So in the next upcoming lecture, I'll be talking about the other questions that is related to a continuous random variable. Thank you.